let's see if that stops it right there. Then there's a welcome and overview of Physics 11, a syllabus, recommended and optional textbooks, and then some words of advice. So as I said about my recent knee replacement, I'll just let you read that, but that's effectively saying what I said, that there's a goal, that for the first 3 weeks, I'll be online. After that, I should be in the class. And I'll be lecturing from a tablet initially. And I will also be able to get up and do, demonstrations during this period here. So if I click on this, what you're going to see here is that this gives you a brief overview of the course. And our lectures are going to be Monday and Wednesday from 12:40 to 2 p.m. So up to September 14th, they'll be on Zoom, which I've given you the link. And then I will record these and upload them onto YouTube. After that, we should be face-to-face. There are 2 lab sections in room 802, which is next to the lecture room. The first lab section meets on Tuesdays and Thursdays from 12:40 to 2, and on Tuesdays, that section goes from 2:10 to 5:15. All quizzes and exams are going to have to be completed online via Canvas. And so that means here is that you have to be prepared to upload a solution within the allowed amount of time. Now, the thing about this here is that if I give you a quiz that's 45 minutes, that means you have to write a solution for it, but it's got to be faster than 45 minutes because you have to create an image and upload it into Canvas. I would prefer if it's PDF, but if it's an image, it's an image. The way the quizzes work here is that the quizzes and exams are going to open at 6 a.m. and they close at midnight on the same day. Okay, so then if I go to the problem sets and the lab write-ups, they have the same process. That means that you're going to have to upload solutions and your lab write-ups onto Canvas by the required due dates, and we'll look at these. And then there are these things called PLC assignments, which I'll talk about a little bit more later. And what you're going to see here is that these PL assignments are these to-be-arranged hours. So what does that mean? That during the week, you will be required to do an assignment that's about, you're supposed to spend about an hour. So we're shooting for 50 minutes. Some assignments are going to be a little bit longer. Some assignments are going to be shorter, but the overall semester, we should have them, we should be able to, average it to about 50 minutes here. And these are going to have to be checked off by an instructor in a PLC or a PLC tutor in the STEM Center. Again, we will look at this a little bit more in detail later as to why a PLC is important. All labs are in person. Okay, all labs are in person. Now, let me go back. And then I want to go through the syllabus. So if I go through the syllabus, here's my course information. I have a telephone number. But guess what? The first 3 weeks, I'm not even going to be in my office, so it doesn't make any sense. And typically, I'm in lecture or in the lab most of the time, so a telephone call doesn't work well. What's the best way to do? Send me an email, either Canvas or via this cabrillo.edu email. And typically, I respond pretty quickly. And so what you'll find here is that there's these prereqs. I saw that most people had already done that. I have a link for the Zoom lecture, a Zoom link for the office hours. Once I go back face-to-face, this office hours link is not going to be used. If you have any issues with Canvas, here's a link that tells you how you could get help for that. So now let's talk about the textbook. The textbook is effectively none. The textbook that I like and I follow closest to is what's called College Physics, A Strategic Approach. And it's by Knight and Friends. But any other algebra-based textbooks works pretty well. Okay, this information is not new. So to give you a sense of this, if I go back, you'll see here is that there's this link here on this course information that talks about recommended textbooks and optional textbooks. So when you look at this, I've been at Cabrillo now for 25 years. Research as well as experience that the vast majority of the students don't read the textbook. So why would you spend $200 or more on a textbook if you're not going to read it? That's what I'm going to say. So past experience shows me that most people rely on my lectures. I'm going to start posting my personal lectures, but because we're on Zoom, you'll see that you'll get the Zoom lectures just as well. You'll get a video link and you'll have a link to the lecture notes that I wrote. And that has been sufficient to complete, right? To complete the problem sets, pass the quizzes, and pass the exams. That's been my experience. However, I think that this textbook, especially by Knight, the algebra version, is one of the best books written today. It is, I think it's phenomenally done. And it's one of my favorite textbooks, believe it or not. And so what I did here is I did not list this at the Cabrillo bookstore, okay? I chose not to list this at the Cabrillo bookstore because I think they rip you off. Look at the price of the textbooks. And if I remember correctly, I saw even higher prices, but this was sort of like the average. Now, I just went to Amazon, but there are other places that you could buy it. So if we went to this Amazon link, here's the 4th edition copies. And if you go to the link that says other used or used forms, I found like about 30 copies of the 4th edition, the current book, that were somewhere between $7 and $20. And then there were some that were about $25 or $30. So you could save a lot of money buying a used textbook. So my response is, if you don't read the textbook, don't buy it. I'm going to give you all the problems. I'll provide you with my personal notes, as well as in the initially the video lecture notes, as well as the written lecture notes. So if I go back to here to my syllabus here, let's keep moving on. So now I've talked about the textbook. So now that I have the textbook, we have these learner outcomes that says that this is what you're supposed to be able to do after you finish this course. And I'll let you read this right here, okay? So it's just some basic learner outcomes, as it says. Now, let's talk about academic honesty. With online, it is becoming really clear that there's a lot of plagiarism and academic dishonesty. And you want to be careful. Now, here's a link to this little thing that defines plagiarism and academic honesty. And I'll let you read this, but this is really important here. And this is what I'm looking at. Collaboration on quizzes and exams or plagiarizing the work of a colleague or a website is strictly forbidden and will result in the failure of this course and the full extent of disciplinary action by the college. So let me talk about a couple of things here. This summer, I taught a course called Physics 4C. And in Physics 4C, the vast majority of the people were not from Cabrillo, but by the way, Cabrillo students cheat just like other people from other schools. So what happens here is that because you're uploading, I could easily look at quizzes and exams, and I could tell immediately whether somebody cheats or not. So this summer, I had a class of 48. I finished with 35. 6 people I caught cheating on quizzes. And what did I do? I dropped them from the class. I gave them an F, and I reported them to the college. And there was another time, I think it was the last time I taught this was like 5 or 6 years ago. Actually, it was right when COVID started, so it can't have been that long. No, I think it was before that. And what happened is that I have a tendency to write quizzes that have funky wording. And one of the wordings that I put in there is that I said that Carlos, and I'm referring to me, stayed at a cheap motel, and he was wearing sharp, pointy boots, and I was chasing cockroaches in a corner of this cheap motel. So after the quiz was taken, what did I do? I went and I Googled those words, and I found where people had uploaded them to sites that give out physics solutions. Well, guess what? With the help of the college, I got the emails of those students, and guess what happened? I dropped them from the course, gave them an F, and reported them to the college. My job here is to protect the people who are being honest. You want to be careful. Just do your work and you'll be fine. But if you try to be, slippery and cheat, sooner or later, you're going to fool some people. But if you get caught, you're not going to fool everybody all the time. Okay, moving on. So here's a non-discrimination and accessibility notice. So if you need accommodations, you want to make sure that you talk to the Accessibility Support Center, because it's important that you get those accommodations right away. Okay, and you should not be shy about them. I strongly believe in accommodations. Okay, so here we go. Now let's talk about the grade assessment. So the grade assessment is over problem sets, PLC activities, lab reports, quizzes. There's going to be 2 exams and 1 comprehensive final. And you could see that the weight of this course here is well distributed by all of these pieces. Okay, by all of these pieces. So if you don't do any of the PLC assignments, for example, the highest grade that you can get is 90%, but let me tell you, it's very unlikely that you're going to get 90%, that you'll get all of the points. So you need to do all of these pieces. So here we go. Problem sets. So what do I mean by problem sets? Problem set solutions are assigned and have to be uploaded to Canvas. Let's go look at them. Okay. So if I go to look at these things here, I'm going to go to the first module. So when you go to this chapter 1, you could see here it says problem set 1. So let's click on it. So what you're seeing here is that you get a link right here. And that link gives you a Word document of these problems right here. And if you click this link, this will give you a PDF download. And you're going to see a series of questions here. So here you can see this is question 1A all the way through 1D. So I'm asking you to answer these questions right here. And then there's a second piece that has problems. And so you could look at problem 1.1 and note, I gave you an answer for that problem. Now, I'd like to think that I have taken care of all of these answers and made sure that they're correct. Could I have errors? Of course I can. but I would suspect that most of them are correct. So what you should do is that you should download these problems. I put these up here because if I made a mistake on these problems, it's easy for me to correct the answer so that everybody could see if I made a mistake or not. But it will be the most updated. And you could see here that in this problem set, there's about, there's 9 problems and 4 questions. So there's a total of 13. So over a week's time, I suspect that you'll be able to do that. So now, when you get to this, when it's time to upload, I would prefer that you do a PDF. You take an image of this, and then you upload it into Canvas here. Okay. Now, some people have issues with uploading some things here. So what I'm going to do here is that I'm going to show you a way to upload if for some reason you're not able to upload more than one document. I prefer that you upload one document, not multiple ones. So here's what you're going to do here. So if, for example, you were not able to upload a second page, look what I'm going to do. I'm going to go to grades. Okay. If I click on grades, and what you're going to see here is that it's going to give everybody's name here. Okay. Everybody's name. So now what I'm going to do here is that I'm going to go to my test student. So if I click on my test student, what you're going to see here is that it should have your name, and it will have, just basic information of that. But what you need to do here is that you need to click on grades. So when you click on grades here, note that it has all of the assignments here. So what I would do then is that I would now click on this problem set 1. And when you click on problem set 1, you see how it says attach a file? You click on attach a file, you find it on your computer, and then you upload it. So when I go to grade it, if I see that a file has been uploaded in the right amount of time, then guess what? I'm not going to charge you any penalty for being late. So that's not a problem. If you put a comment here, I will not see it. So don't put a comment here. If you want to tell me that you attached a file, then you send me an email and say, hey, I attached this file to this thing. So when I go through, I know what I'm looking for. Okay. So remember, use this attached file because it's extremely useful when you get into a bind when you're trying to upload things right as the deadline is coming up. So if I go back to the problem sets here, you could see here is that this is what I'm going to be looking at. So the problem sets here is when you look at that here, your success in this course will depend largely on the effort you invest in these. Your number one goal in this course is to put your vast majority of your time on the problem sets. Number one goal. Because if you do the problem sets, then, and if you understand them and you put your time in, guess what? You're going to be able to do the quizzes and exams and fare very well in this course. In fact, because the problem sets are so important, if you go back to the course information, look where it says words of advice. So if you click on this thing, it says, when you study, emphasize materials in the following order: lectures, problem sets, and readings. Okay? So now it is imperative that you keep up with the problem sets. Proficiency with these concepts only comes with sufficient practice and the concepts build on each other. A word about problem set. It is not something that you just throw together and turn in to get the points. Problem sets is critical practice for quizzes and exams. You want the work you turn in to be neat and organized. I want to see the work used to solve the problems, not just the answers. Let me tell you what happened on 4C, on quizzes and exams. Problems were worth 20 points. And if you gave me the answer, I want to congratulate you that you got 2 points. Even if it's right, you got 2 points out of 20. I want to see the work used to solve the problems. That's where you get the points. Even if you get the wrong answer, the vast majority of the points, let's say if you had done the whole process and then screwed the last numerical answer, you know what I'd probably take off? 1, maybe 2 points at most. So you would have gotten 18 out of 20. Your work should be clean with good space between them. Do not try to save paper by cramming everything into as tight as possible. Make the effort to turn in something that you are proud of. I promise you the added effort will result in improved study skills that will bring rewards throughout your entire educational career. Man, I can't stress to you those words of advice. Problem sets are everything. They're everything in this course. Everything else is secondary. So then, going back to the syllabus, then what I'm going to do here is that the problem sets are going to be graded from 0 to 4. And I'll let you look at this rubric to do that. Then we have quizzes. All quizzes will be completed online. Again, we said this earlier, they open at 6 a.m. and they close at midnight. You have to upload your quiz solution into Canvas. If you upload your quiz, let's say at 12:01, am I going to accept it? Yes. If you upload it at 12:30 or 1 a.m., no. Each of the quizzes are going to be about 2% of your grade, roughly. The same thing happens with exams and final exam, the exams and the final exam. They have to be completed online. Again, they open at 6, they close at midnight. We'll have 2 exams and 1 comprehensive final. And we're only going to cover exams 1 and 2, only the stuff that we covered during that spot. During that, like you'll see exam 1 is going to be chapters 1 through 6. Exam 2 is going to be 7 through 9. And then the comprehensive final will be 10 chapters. So let's talk about the drop-in physics, the drop-in PLC. The PLC, we should talk about the PLC. The PLC is a drop-in physics lab. It occurs in room 834, the STEM Center, and Physics 11 is required to spend 15 minutes of arranged time. What do I mean by arranged time? That means you just got to spend it within, the week. You got to spend 50 minutes in there. And how do I know whether it's 50 minutes? I'm just guessing. But practice over the years has told me that, that I more or less guess what it is. The idea here is PLC activities are designed for support conceptual learning of the material using ranking and applet questions. Okay, so now why do we do this? Okay, so let's talk about this. So what we want to do here is that I want to go in here and I want to sort of like be a little bit more clear. And this is what happened in the past. What happened in the past is that When I came to Cabrillo in 1998, the pass rate for Physics 11 and Physics 4A was around 60%. There was a guy named Doug Brown who was an instructor here just like me, and he had a sabbatical where he traveled around the country looking at physics departments to see how did they support their students the best. And when he came back, we ended up developing this Physics Learning Center. And the whole idea of the Physics Learning Center is to try to form small, effective groups that work together, that are effective working groups to solve problems together. The idea is not to work by yourself, but in groups. Research shows very strongly that people who work in groups are more successful at passing Physics 11 as well as passing Physics 4A, 4B, 4C. So as a consequence, we developed this course. We have a list of questions. They're typically ranking. Some of them require drawing graphs. Some of them are small, one-of-a-kind experiments. And the idea here is that you work in a small group. My experience is that the groups are typically around 3 to 4. I've seen them as big as 8. And what you do here is that you work together as a group. And when you complete that assignment, you guys go to a tutor or to an instructor like me, and we will check to see whether you have it correct or not. If you have it all correct, then only one of those sheets has to be shown to the tutor or the instructor, and we will check everybody off on a sheet that has your name. You don't turn it in. It's just practice for understanding conceptual, understanding of the material. When we have exams, one of the questions on the exam is going to be a PLC type ranking question, which expects you to explain it physically. When we implemented this, it took us about 3 to 4 years to actually get it right. The pass rate from Physics 11 and 4A, which was in the low 60s, went up to the low 80s. There was 20% plus increase in the pass rate. And my experience is that if you stick around at Cabrillo, this course starts to create foundations for 4A, 4B, 4C, 4D, as well as other engineering courses. So it is worth working and finding a small effective group. Physics is meant to be, it's in the discussions between people, not by people by themselves. Am I going to be policing you to say, hey, you're not doing the PLC, with other people? I'm going to encourage you, but I'm not your father. I'm going to encourage you. That's all. And if you don't want to do it, okay. But it's not as much fun, I'll tell you that much. And some of the questions will get more challenging as the time goes on. So your goal here is that the first week there's no PLC, because we're not allowed to have tutors in the first week of school. The second week of school, you will have 2 PLCs. So if I go and I show you what do I mean by this, let me go back to this guy here. Let me go home. And what you're going to see here, let's look at the first PLC. So the first thing that you want to look in this chapter 1, here's a tutorial on the use of significant figures. So if I click on this, this goes over tutorial. Here's a doc, and here's a PDF. And you're supposed to get familiar with Sig Figs. By the way, you may be an expert at Sig Figs already. I'm just making sure that you know the basics of Sig Figs here. Now that we have that, you're going to see here is that the first PLC is a fairly light PLC. So this is due Tuesday of next week. So when you click on it, the idea here is that here's the first PLC on Sig Figs. So what are you supposed to do? You could see here's question 1 all the way to 11. Answer these questions. Then go, when you think that you are right, you're going to walk up to a PLC tutor or an instructor, and what they're going to do here is that you're going to check it for correctness. If you missed one, they're going to hand it back and say, go correct this one. Once it's complete and everything is right, then you get full credit for the PLC, and that's it. And then sometime during the semester, after about 5 or 6 PLCs, I will then go in and enter your grade. It's either you completed the PLC, which is 4, or you didn't, which is 0. It's that simple. So that's the PLC right there. So now, if I come here, we've now hit the problem sets. We've talked about, we talked about PLCs, and then we're going to talk about labs. So labs are due every Tuesday. There are 2 lab sections in this course. One is Tuesday, Thursday, and one lab is just on Tuesday. Those labs are due every Tuesday by midnight. After that, they're considered late. And I am not going to be probably there for the first 3 labs. I'm hoping I could be there for the 3rd, but definitely not for the first 2. And when you look at the labs, they're very hands-on. So, for example, if you look here, here's lab number 1. So if you click on it, this lab is all about unit measurements. So I typically have an objective, what equipment you need, then I talk a little bit about theory. So tomorrow when you come into the lab, there's going to be a team building. Okay, and there's going to be Paul and Julia that are going to conduct some team building activities so you could meet the people in your group, and hopefully they'll talk about that. Just because you sit at a table, it doesn't mean that you're going to like the people that are in your lab group. I always find it really, really interesting. Once you sit down, and by the way, I've been in academia 34 years. Once you sit in the classroom, once you sit on a lab bench in the lab, somehow people feel that they have to sit at that spot for the rest of the semester, even though you may hate the people that are in your lab group. And you know what you're going to do? You're going to be a dumbass and stay in the same lab group, even if you don't like them. The idea of the team building activity is to don't get stuck in a lab group that you don't like. Look for the people that you like. Okay? Look for the people that you like. That's the people that you want to get into. Don't get into a group that you don't like. And so they'll explain this lab 2 here. And what you're going to be doing here is this whole lab is about guesstimating. Just distances. Because you're from, I'm assuming you're all from the United States. You don't think in meters. There's no way. So the idea is the standard units are meters, and you get a couple of references. You get a diameter of a penny, and you get a length of a meter stick. And that's your only reference. And this can be a really, really fun lab. Very, very, very hands-on. Very, very, very hands-on. Okay, so that's the lab. And again, we'll talk about how to get those lab write-ups after you do the first lab. I'll talk about it again before we do that. And that's it. So now you could see here is that I have lectures and examples. So what am I going to do today? You're going to find here in the lecture, okay, I'm hoping this comes up. You're going to see here is that this introduction, I'm going to post right here. Any lecture that I do, like lecture 1.1, I'm going to post here. It'll be a separate video. And then I'm going to post the notes that I'm going to write down right here. Okay. And you'll see here that these are the examples. You could download the examples. Again, you could see that there's a doc file, docx, and a PDF. And I put these here just because it's easier for us to look at these things instead of having to bring up a PDF file or something here. And then if I use any links, you'll see that I'll post them right here. Okay, so what I want to do here is that I want to stop and I want to see, does anybody have any questions that you would like to ask?
I had one. I was just wondering, is the in-person lab tomorrow at the same time as this meeting?
It depends on which lab section you're in. If you're in Physics 11-1, then the lab is at 12:40. And you'll be there Tuesdays and Thursdays. If you're in lab -2, then the lab meets only on Tuesdays from 2:10 to 5:15. Okay.
Okay, thank you. Yeah, I just checked and I think I have Tuesdays and Thursdays one, but at the same time.
Yeah, so it would be exactly at this
Thank you.
time here. Okay, no problem.
Sounds good.
Okay. I also have a question. So for the lab tomorrow, are we meeting in person still, even though you are?
Yes, I will not be there.
Okay.
You cannot do labs in online. We could set it up that way, but no, labs have to be face to face. And this is it's only temporary that I'm not going to be there. And by the way, I said that the lectures, that the problem sets were the most important thing. The second most important thing, which is a close second, is the labs. I think that you're going to get the most out of the problem sets and the labs to pass this course. I mean, to really sink in the physics. Does anybody else have a question?
Yeah, I do. Is the room 834? Is it just like always open?
It's not always open. To be honest, I do not know the hours, but I can tell you what the hours were last semester, and I'm expecting that it has not changed. It typically opens at 9 a.m. and closes at 6 p.m. Monday through Thursday. I think they close at 4 o'clock on Friday. And then on Saturday, I think it's open from like 12 to 5 or 10 to 5, something like that. Now, if right now, if you wanted to attend the lecture in room 804, we could set it up that you can actually walk in and we could have the computer and the Zoom link up so that you can watch it right there. If that's useful to you, just send me an email or tell me so now, and we could do that all the times. Okay, any other questions?
Yeah, regarding problem sets, the questions that you give us the answers to already, we're supposed to do the work for those?
Yes.
Okay.
Now remember what I said here. If you have a quiz or an exam and you don't show me any work, to me, that's nothing. I am most interested in how you think, not what numerical number you can put down. And the only way you do that is you got to show me your work. Are there any other questions?
Yeah, for problem sets, you just like we'll just submit them as a PDF, right?
If I would prefer a PDF.
Okay.
Yeah.
Awesome.
I have a question.
Also, oh, go ahead.
Thank you. The PLC activities, there's not one due this week, but the first one is due Tuesday. Is that correct?
Yes, and then the second one's going to be due next Friday.
Okay, thank you.
You're welcome.
Yeah, so for the problem sets, I see that the first one here is due on the 6th. But generally when we have those problem sets, when would be a good time to complete them? Like just after the lecture? Should we do them before the lecture? That sort of thing.
I mean, frankly, you're asking a really hard question. And the reason why that's a hard question is because it depends on where I'm at in the course material. If maybe you've had physics background before, some people will be able to, know how to do the material before that. The idea here is that, today and on Wednesday, the goal here is that, and maybe part of Monday, Monday of next week, I'll be able to, complete all the material so that when you go to the problem set, you should have no surprises. My philosophy in teaching is if you go to a quiz and an exam and I surprise you, then I did a very poor job of teaching you. My job is to get you to critically think, and it should follow exactly like the problem sets. And that's the way I'm going to write my quizzes. That's the way I'm going to write my exams. No surprises. So if I've completed the material, some of them may be hard, but once you're done with it, you should say, okay, that was everything that we've been working on in the lecture.
Got it. Thank you.
Okay. Any other questions? Okay, so what I'm going to do now is that I'm going to go in and I'm going to write a little bit more on my introduction page, but this time I'm going to write on my tablet so that you can actually see it. And what I want to do here is that I want to go through this briefly. I don't want to spend too much time on this, but I think it's important that you have an idea, a picture of what we're looking at. Okay, so my understanding is that you should be seeing my tablet now. So if I look at this sort of like organization of what we did right here, I'm going to say that if I look at my organization here, of this introduction, the first thing that we did here is that we talked about the course structure. And hopefully we have all of these things have now been settled. The second thing that we want to ask here is that I want to start with the simple question of what is physics? And then I want to briefly talk about something called the scientific method. And I'm sure that you have been exposed to it in some shape or form. And then I want to talk a little bit about the mathematics. Okay. So what I want to do here is I want to do that. So what I want to do here is that let's start off with the first question. Okay. So the first question I want to look at is and I'm going to ask the question, what is physics? So when I ask the question, what is physics? I would say it's the study of all nature at its most fundamental level. And if we're talking science, physics is clearly the basis of all science. I don't think there's any doubt about that. So I would say here is that it is the study of all nature at its most fundamental level. And we could see this immediately. And I would also say that it's the basis, right? It's clearly the basis of all science. So here we go. So let's see if I could do a tree. So if I think about a tree here, I imagine, or maybe not a tree, but a flow chart. So when I think about physics, what do I think about physics here? Physics has very few principles. That's one of the things that I really love about physics, is that I don't have to remember a lot of stuff. So one example here is that you could look at atomic structure. When you look at atomic structure, it has a nucleus, which has protons and neutrons, and the protons and neutrons interact with each other inside the nucleus. And if you kept going deeper inside the protons and neutrons, you would find that there's an interaction of these things called quarks. So just to study the nucleus, you keep breaking it down to its most fundamental level here. So when we talk about nuclear interactions, people talk about, it's how protons and neutrons interact with each other. But at the physics level, that's not what it is. It's how quark interactions occur. That's what I mean by, once again, the most fundamental level. And then outside the atom live electrons. Now, how they live is a complicated question. But there's two parts to the atom. There's the electronic structure, and then there's the nuclear structure. So as you start moving down in my flow chart, what you're seeing here is that now you start to look at, let's say, chemistry. So can chemistry be more fundamental than physics? The answer is no. A large part of chemistry is essentially how electrons interact with other electrons of atoms. And the big difference between physics and chemistry is that physics has very few principles, and therefore you don't have to remember very much. These guys have many things to remember. I remember when my roommate in college, who was a biochemist, and the amount of stuff he had to remember, it was insane how much he had to remember. Physics is more fundamental. There are fewer principles here. And what you're going to find here is that really causes a problem for some people. Because what you find here is that these people want a simple answer. You don't get a simple answer in physics because you have to deal with principles. You have to deal with principles. And then if I continue, the most fundamental, the most integrated science is not physics. It's definitely not chemistry, but it's definitely biology. Biology is without any doubt an integrated science. What do I mean by that? Well, in order to understand biology, you need physics. Ooh, if I could only write physics now. In order to understand biology, like for example, if you're looking at the heart, well, the heart is effectively an electrical pump. And if it's an electrical pump, then when you start to look at what actually moves across those walls, it's a chemical reaction that's actually calling that. And then if you start to look at the biology of this thing, right, we're talking about contractions of muscles and stuff like that. Man, biology is, man, that's a tough one because it is a true integrated science. So when I say it's the basis of all science, that's what I mean by physics. Does that mean that physics is more important than biology? Of course not. More important than chemistry? Of course not. All I'm saying is that it's a basis here. Now, there's lots of wonderful reasons to study physics. I mean, incredible reasons to study physics. I mean, why is the sky blue, for example? When you look at the sky, we see a blue sky, but actually, blue light is not what's scattered most. What's scattered most is actually violet light. When I was a graduate student and I applied to work as a graduate student at the Stanford Linear Accelerator Center, you had to take an exam. And the very first question on that exam is, why is the sky violet? The reason why we see a blue sky is because our eyes are better at seeing blue. And, you know, we could keep going on. You know, one of the things that we're going to be talking about is we're going to be talking about, you know, Newton's laws. Newton's laws are amazingly beautiful. There's so much power and, you know, in looking at these and trying to apply this to every day. But there are so many wonderful questions in physics that, you know, we'll try to get to some of these here. So let's go to the second question. The second question that I want to talk about, just very, very briefly, is called the scientific method. So the scientific method is usually a three-step process, but I would say that in practice, it's a four-step process. So what do I mean by a four-step process? Well, I would say that there is a step 0. And what we want to do here is that one identifies something very interesting. You see something that really piques your interest. So you identify something that's really, really interesting and know very little about it. You know very little about it. So the scientific method is essentially a process that tries to give you an idea of how to approach and learn as much as you can. So then we go through the steps. And this is what the vast majority of the people put. They go step 1 and they'll go, you have a hypothesis. You observe something, and then a hypothesis is nothing but an educated guess. Right? I can't tell you how many times people say, I have a theory. You do not have a theory. You have a hypothesis. It's that word has been misused too many times. Okay? Too many times has that word been misused. And what you'll find here, you have a hypothesis, and you'll see, what do I mean? And then, as soon as you have a hypothesis, then you make a prediction. And so when you make a prediction, what this is here is that it's a consequence of the hypothesis. And so what happens here is that this is where science really, really, it really excels. By the way, I just noticed the chat. It says, I thought it was blue because of reflections from the ocean. Why the sky is blue? That is not correct. It is the light from the sun scattering off the gas particles in the atmosphere. And it turns out that when light scatters off of gas particles, because a lot of the light has a smaller wavelength, they see smaller stuff, and the light with the smallest wavelength is violet. The very next color with the next smallest wavelength is blue. And it is blue that is scattered the most, and therefore that's why the sky is blue. That is called Rayleigh scattering, if you wanted to get more details into that. Now, check this out. Have you ever made a guess of something, and as soon as you thought about it a little bit more in detail, you realized that it was incorrect? Yeah, here's where science really starts now. It goes like this. So you make, from your hypothesis, you make a prediction, and then you realize that your hypothesis was incorrect, so you go back and you change your hypothesis. And then you think about it a little bit more because you're making educated guesses, and this process just goes back and forth again and again and again. Science is a messy process, not a clean process. There's a lot of times where you'll see that people say, I have a thought, and then all of a sudden they go into the lab and they actually do that. That's bullshit. That's about as far from the truth as could be. So once this prediction, has gone through exhaustively, through hypothesis, prediction again and again, then the most important thing in science is the experiment. The experiment is there to test the prediction. This is the most important part of the process. The experiment is by far the most important. Okay? By far the most important. There's a time that people say, in science, we don't care about your opinion. I don't care how you feel, period. Science is about experiment. Experiment is the truth of nature. There is true that sometimes how you interpret what nature is can get complicated. But nature is reality. not the other way around, not what you think is going to be it. So here's how science really operates in the language of science. It goes like this. When predictions pass the scientific method, numerous times, not just once, but numerous times, only then do scientists call them theories. And if they get really good, these theories, they're then called models. Like there's a standard model of the universe, the expansion of the universe. They don't call that a theory. They call it a model. Why? It's battle tested again and again and again. There's a standard model for particle physics. For the same reason, they don't call it a theory. Just like evolution. It's a model, not a theory. And that's because models are more important. But note, how many times do you see people say, I have a theory? No, you don't. You have a hypothesis. If it's not testable, you can't call it a theory. Everything has to be tested with experiment. That's the goal of science right there. There's lots of ways to demo, sort of like a, this scientific method. I won't, just because it's not worth doing it without a live demo to do that. But yeah. So the last thing that I want to do here is that I want to talk about mathematics and physics. Mathematics versus physics. By the way, I just saw Lindsay's thing. It says we can't understand you about the scattering of violet versus blue light. It's an advanced topic. So, I mean,
I apologize. It was my internet connection was not well at that moment, so I just couldn't hear you, but I figured it out.
Hey, great. I'm glad to hear that. So there's a lot of people that think physics is math. It's not. Okay? It's not. And so what I want to do here is that I want to give you a flow chart of why they're very, very different. Okay? So let's look at this. And I've already said this, but I'm going to say it again. Physics is the fundamental study of nature. Okay? Fundamental study. And that's what I mean by the basis. And what that really means to me is that this means here is that we use physics concepts to describe, oops. Uh-oh. Let me see if my, okay. To describe a physical phenomena. So a lot of the times when I say the word describe, what do I mean by that? Is that some people have said that physics is the science of pictures. Now, there are people that don't really like pictures. They'd rather use equations, but equations are pictures too, by the way, right? That's definitely a picture. But a lot of the times in physics, you'll hear me say, I want a physical picture. How can you visualize these things? Because some of these things can be abstract. So here we go. So what I want to show you here is that this is the role of mathematics and physics. So I'm going to look at a flow chart. So what we have in physics is that we're going to have some physical phenomena. Very much like the scientific method. We see something that's really, really interesting to us. And this is our physical phenomena that we're really interested. So what we want to do here is that, so with this physical phenomena, we create some type of image in our minds using physics. So like this summer, when I was teaching Physics 4C, I was trying to get the image of an atom into people's head because it's extremely abstract. So I have a physical phenomena, and then I'm going to use physics to create a picture, and I'll go back and forth between the physics and the picture. Once I get this down, what I'm going to see here is that now I'm going to write an equation. Now, why do I write an equation? Because now that I got my picture, the reason why we write an equation is because this is a universal language. If you're Chinese, German, African, whatever it is, in the language of mathematics, it does not matter. And then from this, we then take this equation, and what we do here is that we solve this equation to get a number. That number is huge. So what you're seeing here is that the first piece here is physics. This right here is mathematics. And what I'm saying here is that these two are separate things. But I will say that this number here, this is extremely important. That number is extremely important. So the question is this: why is the number so important? Well, numbers, like I said, is a universal language. And one example that we could say here is that everyday language has words with double meanings. Right? It can be ambiguous. It could be really ambiguous. So here's a silly example. So if I think about this example, somebody might say, hey, Carlos, you're a fat dude. Right? You're a fat dude. I mean, what does that mean? What do they mean by fat? Right? Again, this is a silly one. You might say, oh, you mean that kind of fat. But what you were really saying is that not that kind of fat, but this kind of fat. Right? Where I'm some rad dude or something, which of course that's not true. But that's what I mean by double meanings here. And sometimes what you're going to find here is that in physics, things can get really abstract. And so the meaning has to be crystal clear. And the beauty of this is that numbers never have double meanings. They never have double meanings. For example, if one measures the length of a pencil and it's 15 centimeters, let's say, I don't know, it's about 6 inches, right? So that means if you have a pencil, let's say that this is your pencil here. Maybe you have a yellow pencil. And then you have your point here. And let's say that you have a red eraser. Now, if you come in here and you measure this with a scale, right? You come in here and you measure this with the scale and you read that from here to here, that the distance from here to here is 15 centimeters. What's to debate about it? Anybody who measures that pencil, that number, that has meaning, that is indisputable. There's nothing ambiguous about it. So the idea here is that it goes like something like this here. So now if I have my picture here, then I go back and I go like, okay, this tells me that it's 15. So I go back to my number and I say, oh, this says that it's 15. And let's say here that if this is 15, then I go back and just say, well, that predicts the right number. So I go back and I go, well, we must have written the equation right. We wrote the equation right. And because we wrote the equation back, right, then we go back and we go, that means that the physics and the concepts have a connection to reality. Therefore, the physics is good. So physics and mathematics are not the same. In this course, our whole goal is to look at the physical phenomena, create some image and, or picture in your head using physics concepts. And there are techniques that we will use. We will use these things called motion diagrams to visualize motion. When we look at forces, we're going to use free body diagrams. When we go into momentum and energy, we're going to use bar diagrams to get this picture. And from this picture, we then write equations. And then when you write your equations, we're going to ask you to go do the homework. So if you set up your equations right, then on your homework, that number has meaning. That means, yeah, you'll say, I got the answer right, but it's much deeper than that. That means that the physics that you did was correct.